Okay, so we're going to take notes today over absolute value again. We're going to analyze absolute value graphs. We're going to analyze the graph of an absolute value. So we've got this function, right? We learned about absolute value yesterday. We've got this formula that we're going to analyze, and then this graph that we're going to analyze, and then we're going to kind of work to blend them together. So we go to 64, page 64. We're going to put this page on 64. Now remember, when you're taking notes via a video, you can always pause it to slow it down, to write it, the information, and then when you're ready, you can press play again. We've got page 64. And again, this is analyze absolute value graphs. All right, so remember that the absolute value, the graph of an absolute value, makes a V shape. So absolute values graphs make a V shape, right? Because an absolute value has two answers most of the time. It has one answer over here for the positive and one answer over here for the negative, right? So we've got this graph that for each y value, for every answer, there's going to be two problems put in. I'm making a video.
There's a big thing.
Oh gosh. I'll come over. So x-intercepts, we have one way of analyzing it that are x-intercepts. So our x-intercept is where the graph, the V, right, crosses or touches the x-axis. So when we look at these three examples, right, we have one intercept, which would be 2, 0. Our x value is 2. So our x-intercept is 2, 0. In this one, where there are two intercepts, we have -2, 0, and 4, 0. So when you substitute these values in for the x in the absolute value function, you get 0 as your answer. When you substitute this into this equation, you get 0 as your answer. And then there are no intercepts. If you look here, there are no intercepts, so we would say none. So you can identify the intercepts, the x-intercepts. Then when we talk about the range and domain, right, we've talked about these in linear functions before, or in just whether or not it's a function or not. The domain is the range or list of x values that make it true. So they're all of the x numbers that work. So like what numbers could I substitute in and get an answer? What numbers, what x values could I substitute into the formula and get an answer out? The x values, domain is x. And in an absolute value function, every number can be substituted in, right? Like if you look, because this is a V shape and it opens up diagonally, right? Every number I pick, any number that goes in there is going to work. So it's called an absolute value function. Has a domain of negative infinity to positive infinity. Right? I could substitute negative 82 into the problem. I could substitute positive 684 into the problem. I could substitute negative 1,762,000, right? Any number can be substituted into that problem, right? So my absolute value functions, my absolute value, my x, my domain is literally anything. The domain is the x value, and in an absolute value function, this way, right, the ones that we're working with, I can substitute any number because it's extending infinitely, right? So it's every number. The range, the y, the range is the range or list of y values that make the function true or work. Now this is a little bit different because it's not infinitely going up and down, right? Here it stops. So anything below the vertex doesn't work. In this example, anything above the vertex does not work. Here, anything below the vertex does not work. So it depends on if it opens up or down, but the y value of the vertex is one of your numbers, is how you start your list or end your list, depending on what it opens. If it opens up, it's positive infinity. So for example, here, my y value is 0 to positive infinity. If it opens down, it's negative infinity. So here, I cannot go any higher than 3, because that's where it meets, right there, 3. And the values go down to negative infinity. So like, let's say for number 1 is 0 to positive infinity. Number 2 would be negative infinity to 3. And then the last thing we're going to talk about, domain and range, first one, x-intercepts, right? Then we're going to talk about the end behavior. And so the end behavior is meaning what's going on at the end, the behavior. How does the end of the problem behave? And so we have two ends because it's a V shape. We have a left end and a right end. So the end behavior, what's going on at the end of the graph, the ends. This one has ends, plural, two ends, a left end and a right end. All right, so if the graph opens up, right? If the graph opens up as the function, remember f of x can also mean y, approaches infinity as we go and we continue going up, so our up number is our f of x, or our y approaches positive infinity because we're going up, x approaches negative infinity. On the right side, if it goes up, again, we're going up, so as y approaches infinity, x approaches infinity, because again, as we're going up, our y value goes up and our x value goes up. Over here on the left side, as our y value goes up, positive infinity, our x value gets smaller, negative infinity. If the graph opens down, right, as y goes down, so y approaches negative infinity because it's going down, x also approaches negative infinity. As y, we're going down, or f of x approaches negative infinity, on this side, x approaches positive infinity because we're going to the right.